All right, now that we've had an chance to think about how this L'Hopital's rule came about and to learn a little bit about its history, let's practice it with some specific functions here. So this is the one that we talked about before in the applet. So as x goes to 3, the exponent here goes to 0. So we get e to the 0, which is 1, minus 1 on the top. So the top is going to 0, and so is the bottom. So first thing you should ask yourself, or that I'd like to ask you, is it true that 0 over 0 is always equal to 1? And I hope your answer is no, because as we said, every time we compute a derivative, we're computing a 0 over 0. And certainly not all derivatives are 1, right? Calculus would be a lot more boring and a lot easier if all the derivatives were always equal to 1. We wouldn't be spending all of our time doing this. So what does L'Hopital's rule say we can do with this? It says we can take the derivative of the top and the bottom of the fraction. So the derivative e to the something, we're going to have to use our chain rule there. So that's e to the same something. And the chain rule says take the derivative of the something. So the derivative of 8x minus 24 is 8. And the derivative of 1 is 0 because 1 is a constant. And on the bottom, the derivative of 2x minus 6 is 2. Remember, derivative just means slope. So the slope of 2x minus 6 is just 2. So now let's reevaluate the limit, which is what L'Hopital's rule tells us to do. As x goes to 3, this is still going to e to the 0. So this is going to e to the 0, which is 1, times 8 over 2, which just works out to be 4. Which is what I hope the conclusion we came to in that first applet and in the sketch that I drew on the board in the last segment. So what this is saying is that when x gets very, very near 3, the ratio of the top quantity to the bottom quantity is about 4 to 1, meaning the top quantity is 4 times as big as the bottom quantity. And just to be clear, this is not about taking the derivative of this entire function. If you wanted to take the derivative of this function, what rule would you need to use? You would need to use the quotient rule, right? This is not talking about a derivative of this function. This says for whatever reason we're interested in the limit as x goes to 3 of this function, not the slope of this entire function. If you do want the slope of this entire function, you have to use the quotient rule. So please be sure not to confuse the quotient rule with L'Hopital's rule. They're used in completely different settings for completely different purposes. In fact, the very first edition of our textbook did not include L'Hopital's rule at all because the authors had had such bad experiences with students thinking that now that they knew L'Hopital's rule, they could forget all about the quotient rule. That's not at all true. They're completely different rules, and we don't want to get them mixed up. Let's try another example. X is going to 0, so this is going to 0 minus sine of 0. Sine of 0 is 0, so the top is going to 0, and so is the bottom. So again, we know that 0 over 0 is not always 1. This is an indeterminate form. We need more investigation. L'Hopital's rule tells us what we should do. It says we should take the derivative of the top and the derivative of the bottom. So the derivative of x is 1. Derivative of sine of x is cosine of x. And the derivative of the bottom is 3x squared. So now let's see what they're going to. As x goes to 0, cosine of 0 is 1. So the top is now 1 minus 1, which is 0. And the bottom is still 0. So what do? We can forget all about where this problem came from in the first place. We can say now we have this new function where the numerator and the denominator are both going to 0. How do we evaluate the indeterminate form 0 over 0? We apply L'Hopital's rule, or Bernoulli's rule if we were really calling it by the right name. So what does that tell us to do? It tells us to take the derivative of the top and the bottom. So what's the derivative of 1? That's 0. The derivative of negative cosine is negative negative sine, so positive sine. And the derivative of the bottom is 6x. Okay, so now let's see what happens as x goes to 0. Well, we get sine of 0, which is 0. And on the bottom, we get 6 times 0, which is 0. So we again got 0 over 0, our third time. Should we give up, or do you see some hope coming down the line? In fact, we do see hope because the next derivative, the bottom, is going to be 6, meaning there's no chance we're going to have to use L'Hopital's rule again because L'Hopital's rule only applies for 0 over 0 and infinity over infinity. So we are done after this next step. So L'Hopital's rule says take the derivative of the top, we get cosine of x, and the bottom, we get 6. Now we evaluate the limit. As x goes to 0, the top goes to cosine of 0, which is 1 over 6. So in this case, this is telling us that when x gets very, very, very small, the bottom is 6 times as big as the top. if you were to graph these two functions separately, the denominator and the numerator, the bottom would be 6 times as big as the top. Or this entire fraction would be getting closer and closer and closer to a y value of 1/6 as x got closer and closer to 0. Let's look at this one. Now we have x going to infinity. So if we take a huge number and we square it, we get a huge number. And if we take 2 raised to a huge number, we get another huge number. So this is the other indeterminate form where L'Hopital's rule works. This is infinity over infinity. So that's what L'Hopital's rule tells us to do, is take the derivative of the top and the derivative of the bottom. So the derivative of x squared is 2x. And then for the bottom, we need our exponential rule, our b to the x rule. We get 2 to the x ln 2. Now we evaluate the limit again. Let x go to infinity. What does the top go to? 2 times a huge number will be a huge number. 2 raised to a huge number is a huge number. And we're multiplying by ln of 2, which you might remember from an earlier class is about 0.693. So if you have 0.693 of a huge, 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 huge number, you still have a huge number, meaning we again got infinity over infinity. So we can forget all about where this original thing came from. We now have some fraction that we want to evaluate the limit of, and it happens to be the indeterminate form infinity over infinity. We know how to handle that. L'Hopital's rule tells us what to do. So it says we take the derivative of the top. Now we just get 2. So now we know we're going to be done. There's no chance of getting another L'Hopital's rule because it's not going to be 0 over 0. It's not going to be infinity over infinity. Do we need the product rule on the bottom for 2 to the x times natural log of 2? We do not, because natural log of 2 is a constant. You could use the product rule. It would give you the right answer, but it's not necessary. Normally, we put multiplying constants in the front, but this is at the end. It's fine. So we take the derivative of 2 to the x, which is 2 to the x times ln of 2. And then this is a multiplying constant. So what does that do? Does that stay or go when we take the derivative? According to our constant multiple rule, multiplying constants stay. So now we have ln of 2 again on the bottom. So what's happening? The top is 2. The bottom is 2 to a huge number. So this is a huge number. And this is 0.693 times 0.693 of a huge number. So that's still going to be a huge number. So basically, you have the top is 2, and the bottom is going to infinity. And as we said in an earlier segment, if you have any number, any fixed number, over something going to infinity, the answer is always going to be 0. You take 2 over the biggest number you can imagine, you get a tiny, 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 tiny number. So this is saying which of these quantities is the one that dominates. That's the official math language to use. Dominates as x goes to infinity. In this case, it's the bottom. And it's not by a ratio of 10 to 1 or 100 to 1 or 1,000 to 1. It's basically a ratio of infinity to 1. The bottom is infinitely bigger than the top because the ratio were 0. If, say, we gotten an answer of 1/10, it would mean the bottom was 10 times as big as the top, similar to what we got in the previous example. And here we're only doing 4 examples, but in the old days, your textbook might have had 59 L'Hopital's rule problems in it, and your teacher might say, OK, for homework tonight, do numbers 1 through 59 odds. And you would go through the first 57, and they would all be L'Hopital's rule, L'Hopital's rule, L'Hopital's rule. And then they would see if you're still paying attention, if you're actually checking to see whether L'Hopital's rule really applies, or you're just doing L'Hopital's rule on every problem because you're in the L'Hopital's rule section of the book. So here, what's happening? As x goes to 0, the top goes to 0. That's true. But what about the bottom? We're going to get e to the 0. And e to the 0 is what? It's not 0. It's 1. So in this case, we get 0 over 1. And we cannot use L'Hopital's rule for that. L'Hopital's rule is only for 0 over 0 and infinity over infinity. But 0 over 1 is not an indeterminate form. When you learn fractions, you learn that 0 over any number other than 0 is always what? Always 0. So we can't use L'Hopital's rule for this one, but we don't need it because our just normal knowledge of how fractions work gives us the answer here. And on homework and exams, we will check to make sure that you are not using L'Hopital's rule illegally. For example, in this case, if you did use L'Hopital's rule illegally twice, you would get the right answer just by incredibly good luck for you, but we would notice it. We want to make sure that you're getting the right answer for the right reason. For example, when I was a boy, I used to like to do this with fractions. I would see a fraction like 16 over 64. You know what I would do? I would cancel the 6's. Did I get the right answer? I sure did. Maybe I would see some fraction like this, 49 over 98. I would cancel the 9s. I would get 4 over 8, which is 1/2. Did I get the right answer? I sure did. I might even do this, 19 over 95, just to pick another one completely randomly, of course, I'm choosing these. What would I do there? I'll cancel the 9s, and I would get 1/5. Again, did I get the right answer? Yes. Was any of these things legal? Absolutely not. So please don't try this on your own. We want to make sure that we are getting the right answer for a legal mathematical reason. And now we have a check your understanding on L'Hopital's rule.